I've just clicked, this is Doug Beeman, and I've just clicked on my screen, so you should be seeing it momentarily. I know that most of you are muted, so you can't yell at me if you're not hearing me or something, but I'm trusting that Bruce or Matt will let me know. A couple real quick things. There's two different boxes on your right-hand side, one that says chat and one that says questions. The question should go in the questions section. And you guys, as I'm going through this, I'm not going to be looking at that question section. I do not multitask well, so I can't talk and read at the same time. Well, if Matt... Yeah, if Matt or Russell sees a question that's real specific to what I'm talking about, they'll jump in and tell me what the question is, and I'll try to answer it as best I can, or we'll be looking at those questions at the end. You guys, I know that there's a challenge here in the very nature of having so many people on a webcast. There's a wide range of skill levels out there and experience with Energy Pro. I'm gonna try to cut down the middle of that. I'm not going to try to go over your head, and I'm not going to try to bore you to death. But I'm guessing that with this number of people, I'm not going to hit the mark for every single one of you. I will tell you there's one. What you're looking at right now is the Energy Pro screen. I'm also going to tell you that there's a little bit of a PowerPoint that I put together. This PowerPoint is not designed to answer all your questions or to substitute for what I'm doing, but this PowerPoint, I'll go and put it in full screen here, is kind of like an outline or a note-taking guide to help with some of the things that we're going to talk about today, the main things, I hope. I'm going to talk about the building tree in just a few minutes. I'm going to mention the DHW system, HVAC. You're able to, Matt and Russell will tell you where you can get a PDF of this file, and you can refer back to it afterwards on some of the things like this, building orientation and climate zone. We've put a couple arrows here. Again, if you're just looking at this and expecting this PowerPoint or this file to answer all your questions, it's not going to do it. But if you're sitting at Energy Pro and you're saying, oh gosh, I remember that Doug told us something about orientation, I can't find it, where is it? Well, if you went back to the PowerPoint, you could see where it is inside the building tree, and the arrow kind of points to the orientation and to this climate zone information. So that's what it's intended to be, as kind of a little bit of a reminder to you. And I'm going to refer to this PowerPoint a couple times during the course of the presentation, just to help keep me going and remembering all my points and all that. So, you guys, I am back at Energy Pro. And the first thing I want to tell you about Energy Pro is Energy Pro is used for a lot of different reasons. It was originally written as a non-residential Title 24 compliance program. Then it became, in addition to that, it became a residential Title 24 compliance program. It became a Build It Green tool. It's a HERS 2 tool. It's the tool that we're going to be using today. Because of that, there are some aspects of this program that you're going to say, why is that there? Well, it's there for other reasons, for other programs. It would be nice if we all had this nice, neat, specific little program that just did our stuff. But, you guys, it's a relatively small market for software, and doing it this way, in all honesty, makes a lot more sense for the EnergySoft, the company that's writing this. And so, and it's not all that difficult once you figure out, oh heck, I can figure this out. I'll give you an example right here. I'll go to DHW. I'm looking across the top here. It says heating hot water, chilled water, hydronic, domestic hot water, renewables, exceptional. And you say, well, you know, what all is going on here? For us, all we're going to use almost always is domestic hot water. We're not going to be using hydronic, chilled water. Most of the homes you're going to be dealing with probably do not have chilled water systems on them. So the program seems more complicated when you first look at it than it is. And that's part of what I hope to do today, is to help you see that, help you get off the bottom of the learning curve if that's where you are, or help you understand some of these other aspects of it. So I clicked back over here. The left-hand side of the screen is what we refer to as the building tree, and then this right-hand section has all the details that go into that. How do you get started? You guys, there's a wizard that can walk you through this and help you create a file. I'm going to tell you that unless you are just an absolute neophyte and don't plan on doing this very many times, the wizard's not the best way for you to go. What's the best way for you to go is to create a start file and then always just edit that start file. It will be much easier for you to do. It's a little bit harder to start with, but it's much easier. And when I say that, what I mean is I'm going right up here to File, clicking on File. I'm saying Open. And over here on my computer, you know, I'm looking here just like you would be in any of the Windows programs, Word, Excel, any of them. And I have this directory over here that is called Energy Pro Basics for Build, or BIG and PG&E project. That's just my file name. Those are directories that I created. I guess that's an old term. We call them folders nowadays. And inside there, I have one that's called Start File. And that's what I use. And when I click on Start File, I need to move some stuff. You guys can't see that, but I click on Start File, and it opens my Start File. And the very first thing I do now is I don't edit my Start File at all. I don't touch it. I go in here and I save it. I do a Save As, I do a Save As, and it's my Wednesday training example. And so what I have now is I have my start file there, and I can use it later today. I can use it 100,000 times, but this is a file that already has a lot of windows in it, has a lot of walls in it. It's easier for me to go in and edit an existing file than to try to make one from scratch. So that's my recommendation. And you guys, in this PowerPoint, these are the types of reminders that I have in here for you. File setup. You can use the wizard or you can use the start file. Now, obviously, I haven't told you anything here about how to do a start file, but again, this is a reminder for you afterwards. That's my suggestion. I want to talk about three other things. I want to talk about expand the tree, editing, and help. And if we go back to Energy Pro, and I'm looking at that exact same screen we've been looking at all along. You guys, I assume you know that you have the same copy and paste commands here that you have in almost all of your Windows products. If I open this up a little bit and I get down here and I have a wall here, I have this front wall, I can do a copy. I can come back up here to Room and paste, and it just created a second front wall right there. It duplicated this one, so I have the same commands that you have in all your Microsoft products. In view right there, it says expand tree, and if I click on that, it expands out everything I have in the building tree. And what's the big deal about that? If I got a big complicated house, sometimes I want to see everything. Other times I want to, you know, get this in here a little bit smaller. so I can see more on my page or whatever. So it's a fast way to expand it all out. Last thing I want to tell you is if you click on Help, I can come down here to About Energy Pro, and it tells me that right now I'm working on version 5.1.6.0. If that's not the version you're working on, and just write it down, you don't have to try to multitask. What you have to do is click Help, check for updates, oops, and it will, I'm going to just close this. It will automatically check for updates, and if there's any updates, it give you the option of just updating automatically. And so that's very quick and very simple to do.
Doug,
now,
would it be worth pointing out at this point that they should check the latest version on Compass that Compass is compatible with, and make sure not to update their software to a newer version than Compass, because then their jobs will not get processed properly.
Thank you, Bruce. And Bruce, can we tell them what version that should be? Because I actually have forgotten about that completely.
I believe 5.1.6.0 is currently compatible with Compass, and when you log on to Compass, the landing page that you log on to has a little announcement section right there on the front that says, you know, the current version of Energy Pro that Compass is compatible with is this. And so you can check that every time you log in, and you just want to make sure that you do not update your software to a version that is newer or a higher version than the Compass compatibility, because then you will not be able to calculate your rebate amount, and we won't be able to process your job.
You will be up the proverbial creek.
Yes.
But much more socially stated, Bruce. Thanks. I appreciate that. I appreciate that, the reminder on that. Okay. So you guys, I'm right here on this first line over here on my building tree, and I've clicked on that. I've just clicked on where it says Example House 0914. Pretty clever name there, given that it's September 14th. I've got a bunch of stuff across here, most of which I'm not going to use. You guys, building design data I'm going to use. Building title comes in on my reports. The designer will come in on the reports if I do that. Lighting designer, we're not doing lighting. Mechanical designer, you guys, I don't care if you have an ME doing your mechanical design or not. It's not an issue here. Those are non-residential Title 24 issues. The utility, we probably do need to talk about the utility because of utility cost. Outdoor temperatures, you guys, or excuse me, outdoor lighting zones, that's a non-residential Title 24. Here's our appliances and our indoor and outdoor lighting. We're not using this in this program. So I'm going back over here to building design data. I can put in any name I want here. Just remember that these are things that are going to show up on the reports. I try to use things that are really descriptive to help me remember it, because you guys, I know that those things that are really obvious that I say today, oh, I'll remember this, tomorrow morning, I don't have any memory of it all. Building type is the existing, new addition, existing plus addition. Again, those are Title 24 things. You guys, we're dealing with existing homes. Job number, give it one if you want. Front orientation. Now, this is a little bit, there's two different things here, guys. When we say front orientation, it's how is the front of this house oriented? This comes out on our report. If I say 180, it's going to say the front of the house faces south. These are compass orientations, 0 being north, 90 east, 180 south, 270 west. They do not change. This does not change my calculations. This merely goes through and prints out on the front of my report that the front of my house is whatever orientation I say it is. It doesn't change my calculations. Now there's another line down here that says rotation. You guys, if I put in here 90, what it's going to do is it's going to change every wall orientation. Everything that has an orientation in my building tree, it's going to add 90 to it. I can tell you, if you're a power user, use rotation. If you're not a power user, leave rotation alone and put in the walls at the actual orientation of the walls, the roof, the actual orientation, and all that. Don't try to do it here until you become a power user. And when you're a power user, you don't need to listen to me do this. I'll be boring to you. Okay, so this comes out, the front orientation shows on the front of the page, or it shows on the reports how the front of the house is oriented. This, where it says location, is where we select the climate zone. And you guys, this program is set up for a lot of different countries and cities and states. So I've got United States, California, and then all the cities that have been identified in California are here. If I select Seal Beach, it automatically tells the program that it's in climate zone 6. It automatically selects the weather file for climate zone 6. It uses this winter dry bulb and this summer dry bulb for the heating and cooling load calculations. These temperatures don't affect my energy consumption. Every house in climate zone 6 is assumed to have the same outside temperature. These are only used for your loads. And so if I say Shafter down in the San Joaquin Valley, it's going to have a much bigger cooling load than if I say Seal Beach on climate zone 6. Climate zone 6 is right along the coast. 13 is Fresno, south down to Bakersfield. We'll start there. So you guys, that's orientation, and this is climate zone. And you can see I've selected Shafter there. Project title does not change the calculations. It's information, so you put it in. Designer doesn't change the calculations. You put that information in. Let's go to the next tab. The next tab is DHW. The very first thing says heating hot water. Well, that sounds like that's what I want, but it's not. The program was originally a non-residential program. Heating hot water is a pretty common thing, but this is a boiler. Now, if in fact you guys are doing a combined hydronic system, then you're going to do this. That's more detailed than what I'm going to go into today. What I'm talking about today is more common than that. So I'm going right over here to domestic hot water. The type, well, you know, type is existing, new, altered, removed. You guys, all of these are existing. Even if you're making a change here, and I'll talk more about this in a little bit, don't get tricky here and don't say, oh, I'm altering this or I'm taking it out or whatever. It's existing. Then they call it boiler, but you and I are going to call it a DHW system, a water heater. There are lots of water heaters listed here, and if this isn't enough for me, I could go to import and it says gas water heaters, and I can import just buku water heaters. But you guys, it's not going to do you a bit of good because those are all new water heaters. If the people have installed a new water heater in the last couple of years, it might be listed there. But in all likelihood, the water heater that's going to be there is going to be 5, 10, 15 years old. And it's not going to be one of the water heaters that's here. So I'm literally going to need to make it up. I'm going to need to define what it is. I can click here and I can name it 50-gallon gas water heater, or whatever it is. The type, it's gas fired, it's 50 gallons, The input, 50,000 BTUs. The energy factor, you guys, I know I'm not going to get into how you figure out these energy factors right now. It's when you're looking at a 10-year-old water heater, it's a tough one to know that answer, in all honesty. I'm going to say it's 0.52, and I'm glad that we're muted and you can't ask me why I'm selecting that. I'm selecting a number here based on an energy factor. It's one of the inevitable problems we have with old existing equipment. We don't have energy factors for them listed or published anywhere for the most part. I was trying to recovery efficiency. Actually, you guys, recovery efficiency does not enter into the energy usage for a water heater unless I'm using as a combined hydronic, and most of these are 0.76 to 0.78 today, but it doesn't change my calculations. So there's my 50-gallon water heater. I've got one of them or two of them. Whatever I have, I just change that, and bingo, I'm done with my water heating. HVAC system. My tabs across here: general, distribution, residential, HERS credits, MEC 2. Let's deal with MEC 2E first because it doesn't have anything to do with us. We're never going to use it. So let's go back to general. Again, this name, you guys, what if we have a package unit and a split system? I might want to call this a package unit. And so now I have this package unit, and it shows right here. And what if I use my Microsoft commands and say copy, paste. Oops, I actually kind of glitched that. I meant to say paste right there. Okay, I'm going to say view, expand tree. You guys, I've just defined two HVAC systems for this house. I've got a package unit there, and this one right here, just to make it nice and clean and simple, I'm going to call it a split system. Or I could say, you know, be as descriptive as I want, a 4-ton split system. So I now have two HVAC units here. What that means when I do that is you can see that I have these zones and rooms under each of these. I'm going to need to divide my house up at this point. Let's say the package units on the roof serves the upstairs, the split systems in the garage or wherever, and it's serving the downstairs. I would need to define all of my downstairs area down here, and I'd need to define all my upstairs area over here. And it just, the reason that screen flickered like that is that I clicked inadvertently. So again, I'd need to define the part of the house that's served by this unit here, and I'd need to define the part of the house served by this unit here. If you have two units and they're both identical units, you guys, I could just say that I have this package unit right here, and I've got two of them. And I wouldn't even have this here. Then I wouldn't need to split my house up. Sometimes you can model this really carefully, really explicitly, and I shouldn't have used the word carefully there. You should always do it carefully, but I could do it very explicitly and divide it up by these two package units. And it's not going to make any difference in my calculations as if I do the whole house and say it's being served by those two units. So think about those things as to whether or not they will affect the results of the calculations as you go through. And I know some of you are probably looking here and wondering about my 2 decimals there and how I could get 2.04 units. When you figure it out, let me know, because I don't know the answer to that either. Okay, so there's my general. Let me go back over here And here it says existing HVAC system. I'm going to click that, and it comes up with HVAC systems. And again, I could click on import here, and it's going to pull up all these Trane and Rheem and Carrier and American Standard units that probably are not what your customer has in their house because they're new units. So I'm going to need to know as much as I can about this unit based on maybe there's some literature that's hanging out there with it. Maybe I'm going to have to do it based upon reading what it says on the nameplate. But you can see I've got some tabs across here. And again, all these tabs aren't needed. It's an existing HVAC system. I think we called this one the package unit, so I'm going to say it's a package DX. Guys, look at all that when I drop all that down. Look at all those. Oh my gosh, what in the heck are we talking about? We're talking about commercial stuff. Don't sweat it. Package DX, boom, got it. Heating type, gas. Furnace type, it's a central unit. You know, it's not a wall furnace, it's a central unit. Total output. Well, what's my total output for it? You know, it probably is going to be on the nameplate. The nameplate probably will have input. You may have to figure that out. It's a 78% furnace and it's 100,000 BTU input. Well, guess what? That's 78,000 BTUs output. Does this change anything in my calculations? Nope, doesn't change anything. If you're off here by a factor of 50, doesn't change my calculations. This number down here, my AFUE, does it change my calculations? It's the whole ball of wax on the calculations. So that's critically important to know what my AFUE is. And again, it is hard to know that on old units. Luckily, all I have to do is tell you what to put in here, not how to get it in there. Okay, so the next tab is cooling. If we have a cooling unit, we put in cooling. If we don't, we just say 0 and 0, and we don't have any cooling energy. The program's still going to look at how much cooling energy the house would use. We're in Palm Springs, we say there's no cooling. Well, you know, it's still, that house still would be using some energy for cooling if it had it, and that's what the program assumes. So I don't remember what we had there, but my total output was, it's a 4-ton unit, 48,000, 12,000 BTUs per ton. Most of this equipment has about a 75% capacity between output and sensible. So I got about 36,000 BTUs. How do I know that? Because ask any contractor, what's the sensible ratio on equipment? And in California, it's right at 75%. Close enough. Doesn't change our calculations. What changes our calculations? Bingo, right here, my SEER. That will change my calculations. If I say 10, the EER down here doesn't even matter. If I say over 10, well then this does come into effect. But these older units, 10 is pretty common. I'm going to write in 8.7 here just for the fun of it, just because the EER will always be lower than the SER. This is seasonal energy efficiency ratio. This is energy efficiency ratio. This doesn't take into account the cycling and the duct factors within the system, or the duct losses, cycling and such. This takes cycling into account, and it's calculated at different temperatures, and so we end up with higher numbers. Enough said there. Controls, you guys, non-residential, don't need it. Outside air, non-residential, don't need it. Fans, well, I've got a fan on this unit. It's an indoor fan. Doesn't make any difference here. Don't sweat it. Evaporative cooling, if you have a swamp cooler, you can put it in here, but for the most part, you're not going to deal with that. Curves, these are fan curves. Again, you're not dealing with fan curves. Heating, cooling, those are the two tabs you're going to be working with. So I've changed this one here. Existing HVAC is whatever I've put in here. I tell it OK. and that's what's showing up right there. So to go in here and change this or to modify it, I click that. Distribution. It's an existing distribution system. It's ducted. Both of them are ducted. Well, what if it was a heating only system, or let's say it was a wall for, it was a central ducted heating system, and I had a window air conditioner. Well, the window air conditioner would be ductless. So I might have a situation like that. In this case, because ducts are one of the things we look at, I want to say they're both ducted, but that's how I would change that. Where's my duct location? This impacts the efficiency of our duct system. So are the ducts located in the attic, and is that attic vented, which is our most common situation in California? Are they in a crawl space? Are they in a basement? We ain't got basements in California, so not very likely. If you were dealing with a multifamily project, the ducts might be in a drop-down soffit and they'd be in conditioned space, or you could have that in a single-family house also. But our most common situation is attic vented. What's my duct R value? Right there. And now my duct leakage. Over here it says low leakage air handler or HERS 2 leakage verified. Well, I know that doesn't sound like what you guys want, but it is exactly what you want. So you're going to put in your percentage duct leakage right here based on 400 CFM per ton. So you take your leakage, the small number, the leakage number, divided by 400 CFM per ton, and that's going to give you your percentage right there. And you put that in, and that establishes how much leakage you have. You guys, we're not going to go into detail on this right now, but on the slides here with duct leakage, I've shown that. And if we have more than 30% leakage, there's some documentation required for that. If you get into that situation, Build It Green will be, talk to Build It Green about that. But just be aware that when we go over 30%, documentation is required. Back to Energy Pro. Okay, so that's my duct leakage. Next tab is residential. The only thing I have here is thermostat. Do I have a setback or no setback thermostat? I can change that. Living and sleeping, those are if you're doing a zone system in Title 24, don't sweat it. Just setback or no setback. HERS credits. Now, you guys, most of this stuff is Title 24 measures. Refrigerant charge, I'll hold off on refrigerant charge right now. Blower door leakage, building envelope, building leakage type, it's existing, and when it says type, that just means the building. It's an existing building. And you can do this two ways. You can put in a specific leakage area, and calculating that is really a pain in the you-know-what. So don't do it. Just put in your CFM 50. When you do your blower door test, you get a CFM 50 result. You enter that result right here. So that is your CFM 50, cubic feet per minute at 50 Pascal. That's when you're doing your blower door test. Bingo, you put in that result right there. And I think that takes care of all the HVAC stuff. I come on down to my... Yeah, go ahead.
Sorry to interject here. One more thing. In the distribution under ducts, probably a good idea to point out that if there's asbestos on the ducts, that you can press duct leakage not verified, and that's a good way to deal with that problem. Or if there's some other kind of problem where you can't test the ducts, you want to highlight that.
Thank you. And so you guys, what that does, the duct leakage not verified, is it goes back to the default duct leakage situation, which varies a little bit with the age of the building, 26, 28%. And so thank you. Thanks, Matt. This is labeled, I labeled this zone because that's what this is called in Energy Pro. This is the zone, and the next layer down is room. You guys, and they did this again because of non-residential. You may be going through and modeling a non-residential building with lots and lots of rooms being served by a zone. For our purposes on this zone level, all we got to do is come in here and make sure we say single family. And, I said all, and the floor number. If in fact we have a 2-story or 3-story house, then we want to indicate the floor number right here. So let me show you what I mean by that. If this was, I'll change the name here, if this is the upstairs, I'll call it upstairs, I guess that's good enough. My floor number is going to be floor 2. This zone down here, I'm now going to change the name of it to the downstairs. And that's because it's served by this split system, and we have the upstairs being served by a package unit on the roof. And so this is my second floor. This is my first floor. Click that again. It says floor number 1. You guys, that makes less difference than what you think. It defines this now as a multi-story house. And so for natural ventilation, there's assumed to be more height difference between the windows when you open windows at night to let in your night breeze. 2-story homes have more distance between the windows, and so we get more natural ventilation between them than we do in a single-story house. And that's the impact we're seeing there. But it also reflects that you're modeling this properly. It reflects that when we see this in plan check, we can see that you know how to model it, that you're modeling the first floor and the second floor. Makes it easier for us to review that. So here where it says room, I could leave that at room. I could now call it upstairs again, so that this is more obvious. Now, what's my upstairs area? In this particular example, it's 1,718 square feet with a 10-foot ceiling. If you've got sloped roofs, do an average ceiling height. This is going to change the volume of air inside the house. As you need to be very careful when you're doing your wall areas, but this isn't going to automatically change wall areas. All this does is change those the volume of air calculation inside the house. Okay, we're talking about these 2-story situations right now, guys, and let's take a quick look at this. Upstairs, what I have here, I have a raised floor, I have a ceiling. On the downstairs, I've got a raised floor and I've got a ceiling. Well, the truth of the matter is that might be correct. Upstairs, this raised floor may be the bedroom that's over the garage, and I might have that. But if the whole upstairs is 1718 square feet, the raised floor isn't going to be 1718. When I look at that, I say, oh no, they've modeled this incorrectly. The raised floor area over that garage is probably going to be about 400 square feet or so. It's going to be a 2-car garage or 3-car garage, whatever. So I'm going to be looking for things like that. The floor assembly, it's not going to be an R19 floor over a crawl space. It's going to be an R0 floor with no crawl space, or an R19 floor with no crawl space if it's an insulated one. So crawl space or no crawl space, those are easy mistakes to make. If it's over the garage, it's not over a crawl space. think about it for just a moment. That garage on the summertime in the Central Valley or in any hot area is going to get a lot hotter than a crawl space. So that factors into the calculations. If I say there's a crawl space, it knows that it stays relatively cool down there compared to a garage. So I just changed this to 400 square feet with an R19 floor. No, all that just means no crawl space. I'd look for those things in Plan Check. The program lets you model a house that cannot be built, a house that cannot exist. The program does not build this house internally inside the computer. It lets you put in here anything you want. And that's why the Plan Check has to be done on it, to make sure that you haven't done some stuff, inadvertently of course, that's really screwy. And likewise, I might have a ceiling on my downstairs area. When I look at my downstairs and I see that my downstairs is 17, 18, remember I just duplicated this, that's why those numbers are the same, and I see a ceiling of 17, 18 square feet, again, I know that's probably wrong. A two-story house, the downstairs ceiling is probably not as big as that downstairs area. The upstairs may not cover the whole downstairs. You know, I may have 350 or some number of square feet that isn't there, but probably not the whole thing. Now, since we're looking at this, you guys look at my orientation down here. The orientation of this is 270. Now, we've called this ceiling. When you first do this, it might actually say roof. Let's look at this example right here. If the insulation is up at the roof line, if this is a open beam ceiling or something where the insulation's up here, that roof has a tilt and it has an orientation. If, on the other hand, that insulation's on the ceiling where it's flat, there is no orientation to that, and there's no tilt to it. It's flat. And what difference does that make? You guys, when we have a roof that's tilted and sloped to the west, it's going to get a lot hotter on a summer afternoon than if it's flat. And so, again, if it's ceiling area, then no orientation, no tilt. If it's insulated roof, then we have orientation and tilt on the roof. And in this diagram, we'd have two different roof commands. So we'd change this to roof, and we would duplicate it, make two of them. I'd have one for this side and one for that side. Wall. So this is a very big wall. You guys, I was playing with this earlier today, and I put in that 2,200 square feet. That's probably pretty big for a wall. Now, this is called front wall. You know what I oftentimes do? I also would say front wall / north, if I can spell north. And that helps me with my orientation. It helps me when I'm looking at these things to keep it straight. Remember I told you we have orientation of the house, but now we have this wall. And so then when I come down here to this right wall, the right wall is shown on the west. And that's correct. It's on the right side. Think about a house and the compass, and what's north and what's on the right is going to be to the west. Your left is going to be your east, and so you can see it's at 90, and that rear is going to be at south, 180. Do your walls at the correct orientation. So if the front of the house is facing east, this front wall ain't going to be 0, and I ain't going to call it north. I'm going to call it front wall east, and it's going to be 90. I can either say 90 or I can say east, and whichever way, it gives me the same results. So make sure you have your orientation of your walls correct. Then the windows and the doors are in each of those walls. You can input these individually. You can say this is a 40, 50, window, and you can say it's 20 square feet, and you can go through and you can put every window in that wall and you can label each one of them, or you can add them up. The results will be the same. The chances of you making mistakes and being able to go back and review it, this is easier to be able to review, in my opinion, but a lot of people think it's more work. Now look what we've done here. It says surface type new. That should be existing. And I'm going to kind of jump ahead right at this point because this is an important point to point out, and I'm aware of my time and how quickly it's fleeting. So all of these opaque surfaces get input. I'm clicking down here on calculations. I'm clicking on res performance. That's what we're going to use. And I'll talk about this in a minute, but I'm going to click on alternatives. You guys, and right here is where we're going to select the upgrades we want to do. And this is the only place we do it. And I want to emphasize that 3 or 4 times. This is the only place to do it. I'm going to come back to this in just a moment. If I go to the building tree and I go to this window right here and I say altered, it comes up and shows me existing and new. You guys, if you do this, you are going to get screwy results. These are titled, this is a Title 24 option. It's not an option for Energy Upgrade California. In Energy Upgrade California, you say existing, you go to calculations, res performance, alternatives. I come down here to Windows. I was going blind. And it shows me right over here my options. I've clicked on this and I can put in whatever kind of windows I want. In this case, it's a 0.30, 0.30. If I have a 0.29 SHGC, I'm going to say that. And that's the window I'm going to put in. When I hit calculate up here, it's going to replace every window with that window right there. It's going through and doing the calculations right now. In theory, it's showing me that it's doing something, and it has shown, or it is showing, that if I replace the windows, it gives me a 6.3% improvement for replacing the windows. And it just replaced every window. Now, you guys, this window right here that I've labeled 4050, that actually is a stained glass window that my grandmother installed in the house. And you can go through and you can put in vinyl low-E windows everywhere else, but you ain't touching that window. I've got to have that window. And so the only way I can do this is I come here and I say new. Now I know that may sound screwy. And Martin and I talked about maybe we should have used a different word here, but that's the word. That what that means is that this isn't going to get changed. When we change all the other windows, because this one says new, it's not going to be changed. All these other windows say existing, 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 existing. So when I go back to calculations, res performance, alternatives, select windows, we'll see if that 120 square foot window has any difference. 143.44. $143.85. So I'm not getting quite as good a performance, 6.0 instead of 6.3. So that one window that I labeled as new won't be changed out. And that's your method of doing this. You can do it for a wall. You could, if you're going to insulate all these walls, but this wall you can't, you go in and you tell that wall new. And just remember that technique. And some future version of this will get a better name for that. But that means that wall is not going to be changed when we come over here and we say wall insulation. We're going to put in, I've clicked in the wrong spot. We're going to put in R13. We're going to blow in R13 wall into that existing wall. It says R13. And so now when I make the change, or when I hit calculate, it's going to look at both windows and it's going to look at walls, and it's going to show me those results. So my wall insulation.
Sorry about that, Doug. This might be a good time to point out that this is a different window than some of the older versions of Energy Pro. So anybody who hasn't upgraded to this most recent version won't see this. So don't be shocked by this.
Yeah, you guys, the version, the previous version had all of the options embedded within this. This table was bigger. You know what the table looks like. So it's the same. You still previously you still would have gone to calculate res performance, but just go and upgrade the software. There's no charge for that. Upgrade it, and then you'll have this window here. Thank you. And so this is showing that we have 29.7% improvement for our walls, 6% for our windows, and a total, when we do both of them, of 36.2%. Now, you guys, it says over here, run individual measures or run measures combined together. Let's see what that does when we say run measures combined together. Probably shouldn't have, by adding the second HVAC system, it kind of slowed it down a little bit. So you guys, now it does the two measures, and it just gives me it gives me the first result, and then the second one, it combines it with it. So personally, what I like doing is I like running the individual measures. It shows you the individual impact, and then it gives you the total down at the bottom. One thing that people do is that this will end up getting checked, run no alternative energy measures, and even though you check things off here, if this is checked, run no, nothing happens. So they say, hey, I'm not getting any results. So that could be one of the reasons that you don't get any results. You guys, I've got just a couple more minutes before we're supposed to open this up to questions. Let me show you how to make an XML file. So I've changed that, so I don't know if it'll give me an XML file, but I'll just do calculate one more time, and then I know it will. Okay. So if you look at the difference here, there's wall insulation, windows, and then all. If I had checked 4 or 5 things, it would have given me each of the individual things, and then it would have combined them all together here. And test in home, that means the condition of what you're describing it, however you're describing that house. So you need an XML file to send to Build It Green. If I click on File, I come down to Export, I've got a couple different options here. I can do Title 24 results, a HERS 2, Greenpoint. Oh, look at that one. XML schema file. I tell it OK. And it comes up and says, hey, Doug, where do you want to put it? And what name do you want to give it? Now, it just happened to come up to this location because I did my test at 2 o'clock this afternoon to make sure that I remembered how to do this. But I'm going to give it a name here, and I'm putting it right over here. You know, I'm just using my basic Windows Explorer, not Internet Explorer, my Windows Explorer are options, and I've put it where I want it, and I click OK, and bingo, there's my file. And I can go and get that file. I can email that file. I can do anything I want with that file. So let me take a quick look at my PowerPoint and see what other things I'd wanted to say in my final 2 minutes here. I've got the building tree, the opaque surfaces, the orientation and climate zone, DHW, HVAC system, building leakage. Oh, the test out. Yeah, I want to go back to the test out on duct leakage and building leakage. Multi-story buildings, we talked about multi-story buildings, and I said this is a probable mistake. I've got a slab on grade on the second floor. The second floor has slab on grade, and the first floor has a ceiling. There's only one ceiling in this house. It's on the first floor. I'm going to be looking at this real closely. That's possible, but not very likely. Calculations, we just talked about the calculations, and you check the upgrades that you're going to do right here. You can't do appliances and solar. For a partial upgrade, what we just talked about, specify that area is new, the window or the wall. The XML export file, you go to File, Export, and you select the XML and tell it OK. Then put it wherever you want on your computer. And large water heaters. Let me go back to Energy Pro, and in calculations, right here, it has HVAC duct leakage. And when I check that, upgraded HVAC duct leakage, it's a percentage or a CFM 25 test. You can put in your actual CFM, or you can do it as a percentage. When you were doing your initial test, it only had an option of percentage. And building leakage has the same options we had before. Tested CFM 50, that's CFM at 50 Pascal. You test the house at 50 Pascal, you test ducts at 25 Pascal, and you enter then your target or what you're testing out at. Matt, Russell, Bruce, I'm right at 4:30. I think I should probably go to questions. I'm guessing there's a bunch of questions. So do you want me to do that?
Yeah, if you're at the end of your presentation, we'd love to do that.
Okay. Do you want me to look at these, or have you already got some?
We have some highlighted. Why don't you have a look as well?
We can do the ones that we highlighted?
Yeah, okay. You should see the ones that we highlighted as well.
The green or yellow?
Go to the red.
Red and yellow.
I got green and yellow.
It should be red at the top, but
go to the very top.
We can ask some questions. Well, I'll start just calling them out here. How do we create two zones, Doug?
Okay. You guys, I'm right over here, and if by two zones you mean that I'm going to have units serving each zone, you're going to do it the exact way I've shown right here, where I have two different HVAC systems. If, on the other hand, I'm going to delete this bottom zone right here, this bottom HVAC system.
Want to go over some more questions?
You guys are coming through. You're not muted. Let's say I have one HVAC system, and I want to define the upstairs and downstairs. I've now duplicated that, and I'm just going to need to revise it. Let's say this is my downstairs, and that's my floor number 1. So you guys, I can do zones either way. If each zone is served by a separate HVAC system, I need to make a separate HVAC system for each zone. If one HVAC system is serving multiple zones, I just come right in here with my zones and I make 2 or 3 or however many zones that you would like.
Great.
Gene Freecott had a question about the site TDV energy not adding up. And Gene, I'm not sure if this answers your question, but let me take a stab at it. We've got 2 different things here. We've got site energy and we've got TDV energy. It's actually something I was supposed to discuss, but let me talk about the not adding up first and see if that explains it. Explains part of it. If I'm looking at the energy savings from insulating my walls, from installing new windows, and installing an HVAC system, and I look at the savings of each of those measures individually, it's going to show me, hey, if you insulate your walls, Doug, you're going to get this amount of benefit. Change your windows, you're going to get this amount of benefit. Replace your HVAC system. But if I do all 3 of those at the same time, I'm not going to have the same. I'm not going to have the sum of those 3 as my result, because once I insulate my walls, my house isn't going to lose as much heat in the wintertime, and replacing my windows is not going to give me as much benefit. If I replace my HVAC system and it's now more efficient, insulating my walls isn't going to save as much energy because I've got a more efficient HVAC system. So we have the individual results, and then we have the combined impact of those 3 things, or however many things you have. I also want to tell you the difference between site and TDV is that site energy is what a person pays for at their utility meter, the electric meter, the gas meter, how much energy is coming into the house. TDV is an artificial measure of energy that the Energy Commission uses to take into account the fact that on a hot summer afternoon, electricity in particular is far more valuable to us than it is in the middle of the night in the wintertime. And so they use time-dependent valuation, and they apply this for every hour of every day of the year. There's a different value. So that's time-dependent valuation. It's not the same as what we actually use, but it's a social value that's been applied to electricity to try to give us better messages, to give us better impacts when we're looking at building a house, saying, hey, if you're building a house that is designed so that it uses a lot of electricity on August afternoons, there's a social cost with that because it uses more electricity. So, Gene, I hope that explains why the sum isn't the same, and then a quick discussion of site and TDV.
We have another question on our end.
Okay.
Oh, so their question is, if you're testing duct leakage and you want to figure out the percentage of leakage, is it 21.7 CFM per ton BTUs of heating, correct?
If it's a heating only system, it's 21.7 per 1,000 BTUs. So if I have a 50,000 BTU furnace, it's going to be 50 times 21.7, which is 1,085. I did that in a calculator. So that's my CFM assumption for that unit. If it has cooling on it, always use the cooling value of 400 CFM per ton, per nominal ton.
Great. Another question. For Energy Upgrade California, can we use the RES Performance module, or do we have to use the CalCerts module?
I'm using the RES Performance module. The CalCert's module is actually the HERS 2 module. And Bruce, if you're there, I might defer to you. I don't think they have that option. I think they have to use the Res Performance module.
Do not use the CalCert's module. Use the Res Performance module.
Thank you, Bruce.
Another question, how do we model solar electric in the alternatives tab?
You don't.
All right.
The short answer is you don't. Solar electric does not qualify for a rebate under Energy Upgrade California. And I guess just to remind people, the purpose of this webinar is to teach people how to use Energy Pro for energy upgrade jobs. And solar is not an eligible alternative for an energy upgrade rebate.
Great, thanks. Another question, what if some ducts are located in the attic and some in crawl space on one system?
If it's heating and cooling, you can put, well, if it's one system, you have to you're going to have to take the majority rules here. You're going to have to say, where's the majority of my ducts? The program does not have the ability to come through and say, I've got some ducts here and some ducts there. Now the truth of the matter is that if you wanted to get really explicit, you could put in 2 furnaces here, because 2 furnaces doesn't hurt you in your calculation. But if you did something like that, you're really going to need to document it, so whoever's doing the plan check on it is going to look at it and say, hey, there's not 2 furnaces in this home. So take the majority rule there. Where are most of the ducts at? And you guys, I also probably need this. I didn't explain this either, and I want to jump here and tell you this. Let's say that we have 2 different types of systems, and we're trying to do 2 different types of upgrades on my HVAC system, for instance. You do not have that option inside the program. Inside the program, you have 1 upgrade option. So let's say for some reason you were trying to do a combined hydronic in one part of the house. You're upgrading from a wall heater to a combined hydronic, and in the other part of the house you're upgrading a split system. You can't model that. There's 1 option for your HVAC upgrade. And that's how it is on most of these things. There's 1 upgrade option. That's very common right here with Windows. You may have different U values and SHGC values for the Windows that are being installed. You can go to worst case scenario. You can put in the poorest U value, the poorest SHGC. You could do an area weighted average calculation and provide that calculation along with your plans, but you can't say these windows are going to have this value replacement, this value of new window, and these windows over here. You know, the fixed windows are one value, casements are another, sliders are different. You can't do that. Sorry. It's just that's not a Build It Green issue. That's a software issue.
Thanks, Doug. Another question, how do you calculate in propane usage instead of gas rates for utility?
I'm going to take that question, if I may. So, again, the purpose of this webinar is to teach you how to use Energy Pro for Energy Upgrade California, and at least for PG&E rebates, homes with propane service are not eligible for a rebate. And so the short answer to that question is don't bother, because that home will not be eligible for rebate anyway.
Great.
Thanks, Bruce.
Another question, do you have to do a test out to get the actual quantified calculations?
And so I assume that question refers to duct leakage and blower door.
We're assuming, but yes, you have to do test out measurements.
Okay. The start file, does it come with the program, or will we have to create our own start file?
The start file doesn't come with the program. The program does come with several example files. If you really would want a start file, I'm happy to send you my start file, or I'd send it to Matt and Russell, and they can make it available to you. I can see that it might be valuable, so I'm happy to do that. I'll email that to Matt and Russell after we're done with this, and then if they're looking at whoever's asked for that, or they can post it somewhere, however they would like to do that.
Okay, great. Next question.
I'll skip that one.
How do we remodel radiant heating?
If we're looking here at our HVAC system, our existing system, I'm going to look at system type, and I'm over here. If there's baseboard, there's I'm stammering, guys, because if it's a radiant heating with a combo system or a boiler, you're going to have to do it through where you say that it has a boiler, and it actually is a little bit. People do it all the time, but it's not real quick to do. You can see right here we've got this baseboard heat option. We don't get any in the calculations. There's a slight there's a radiant benefit if we're doing electric radiant heat. But as I'm stammering, you guys, I can't quickly show you how to do that. If you want to hold off on that person, let me see if I can figure out I just can't remember right off the top of my head exactly how to do it. There's Gene out there, or Daryl Kelly probably could tell you. But anyway, yeah. I'm gonna have to remember how to do that. I'm forgetting at the moment.
Okay, no problem. Another question: can eQuest do these calcs?
You guys, that's a question you answer.
So the short answer is no. So the only software that can be used for submitting a rebate application is software that has been approved by the Energy Commission for this purpose. And at this point, Energy Pro is the only software that has been approved. eQuest, I don't think, is even being under consideration. Some of you may know that Recurve is going through the application process and may be approved at some point, and at that point we'll accept Recurve models, but at this point we only accept Energy Pro models for energy upgrade rebate applications.
Great. Next question: how would you like us to figure out square footage of the home?
Exactly. Carefully. You know, you guys, let's think about this for just a moment. I'm not sure of the exact answer here, but when you tape off, when you do your takeoff on the house, you're going to tape it off. I personally am not going to go to more than half feet. If it's 40.5 feet, that's what I'm saying my back wall is. I'm not saying 40 feet 3 inches. I'm rounding to half foot. I'm going to have the same square footage on both sides of the equation, my existing home and my upgrade home. If my square footage is off by 10 or 15 square feet, it's not going to make any difference. My improvements are going to be shown to that same set square footage. So unless we're grossly off, you know, if you say the house is 100 square feet yeah, we're going to get really screwy results. But tape the house, do your diagram, draw your diagram, and then do your takeoffs and your input into the program. And being reasonable is what we would want. I might be getting some more guidance on that. Oh, Gary's suggesting is the question inside dimensions or outside? It's outside dimensions. Oh, okay. That would have made a lot easier answer. Okay. Gary was whispering in my ear.
Okay, thanks, Doug. The next question, for the roof and floor square foot for a 2-floor house, is it correct to divide the house's square footage by 2?
If the floor is exactly, if it's exactly, the upstairs is sitting over the downstairs and there's no garage down there, yeah, that's correct. But that's not a very common situation in California. In my, what's much more common is to have part of this upstairs sitting over a garage, and if the house is been built in the last 20 years, you might have part of the downstairs open all the way up to the upstairs area. So the answer to the question is yes, if it's exactly the same up and down, and there's a floor area over the whole second floor area, then the answer is yes. But that's not the most common situation, in my opinion.
Thanks. Next question, what is the best way to model a drop ceiling with attic above and the knee walls that represent the perimeter?
Okay, so you guys, if I have my upstairs area here, I'm going to take my ceiling and I'm going to model the ceiling area, and I'm going to change this number here just because remember we talked about that before being inaccurate. So that's my ceiling area, and if that's a drop ceiling and it's insulated above or not insulated above, and then I have knee walls, I'm going to come in here, and here where I'm going to click on upstairs, and I'm going to go to edit, I'm going to go to insert. It's actually, I didn't tell you this, so this is a good time to tell you. And I'm going to do an exterior wall. Now, that knee wall is an exterior wall. It's not exterior in terms of weather skin. It's not part of the weather skin, but it's exterior in that there's heat transfer from the inside to the outside being in the attic. So I say that exterior wall, and then I come down here to my exterior wall, and I'm going to, I'm going to call it knee wall. The area of my knee wall I'm going to calculate, I'm going to measure it. It's 230 square feet. It's existing. It's, in this case, I'm going to say it's insulated. I don't know if it really is or not, but I'm going to say it has R11 insulation in it. The orientation of the knee wall, you guys, here, I don't care. I could combine a northeast, south, and west knee wall because the sun's not shining on any of the surfaces. It's all inside the attic. Or you can do 4 different knee walls, or however many, 1 knee wall. So I don't care if you put an orientation on it, because that orientation is taking into account that the sun is hitting it. And it's a 90-degree tilt because it's a knee wall. So there's my knee wall that I've modeled, and I've got the ceiling and the knee wall.
Okay, great. Next question. If I have not ordered Energy Pro yet, what do I order? RM1 or RM5? Both?
I'm not sure what RM1 and RM5 is. It's the you want the residential performance module. And if you were looking at their website and they said that, I'm actually not sure. Do you guys know?
No, we don't. We just were repeating the question.
Yeah, I see it. You guys, if you can't figure it out for their online ordering system, you know, call them and tell them you want the RES performance module, you know, for Energy Upgrade California.
Okay.
Mention my name. Yeah,
Sorry,
mention my name and you won't get a discount.
Next question. If we model an improvement of duct leakage from 25% to 15%, but we do not achieve the 15%, what happens then?
Then what you're going to have to do, and hopefully Bruce is there and he can correct me on this. If I say I'm going to get 15%, it's going to show a certain percentage improvement. If I can only get to 20%, for instance, then I'm not going to get that percentage improvement, and I'm either then not going to be eligible for the program, or Bruce, is the dollar amount dependent on their energy savings?
Yes, it is. So I guess to elaborate on that answer, so as a participating contractor, you're going to submit an Energy Pro model twice. The first time is going to be before you do the job. It's when you're doing it at the planning phase. You're going to submit a model that shows the alternatives as you expect to carry them out with the savings that you expect to achieve, and that's the example there. We start with 25% leakage, and we expect to get down to 15%, and you're going to show us that model. And from that, we're going to calculate the savings that would expect to come out of that and the rebate that would correspond to that. And then you're going to go do the work, and you're going to submit your post-installation rebate request, rebate application. And at that time, you're going to resubmit your Energy Pro model. And if you did everything that you said you're going to do, it would be the same as the pre-installation model. But if there's something that's different, so if you didn't achieve as much duct leakage reduction as you thought you were going to, that second Energy Pro model should reflect what you actually did. So you started at 25% duct leakage, you only got down to 20. That second model you sent us would show that in the alternatives tab, that the final duct leakage is 20%, and so we would calculate the savings based on that, and that's what we would use to determine the actual rebate calculation.
Great.
Bruce, while you're there, there seems to be several questions about Compass. Can you people saying, what's Compass?
I'll say a little bit about Compass. So again, this is a workshop for participating contractors, and if you are a participating contractor, you're aware that Green Energy Compass is the name for the project tracking system that we use to administer the rebate process. It is a system that is, it's free to participating contractors to access it and submit jobs. You have to be an enrolled contractor in order to get the username and password, but once you have that, that's where you upload your Energy Pro model and your work scope and all the other documentation that we review in order to approve your rebate application. What Compass does is it can read the Energy Pro models and actually extract the information out of those Econ2 reports. It's an XML file, and use that information then to calculate the rebate amounts and the other information that we need for administrative purposes. So it's that's all it is to it. There's nothing to buy. There's nothing to subscribe to. If you're not participating in the program, then Compass doesn't apply to you.
Great. Next question. Hold on one second. You wanna say that one?
So the next question is about large domestic hot water heaters and defining standby loss.
You guys, is it 5 o'clock?
It's 5 minutes. We should wrap up pretty soon, yeah.
Oh, we can't wrap up now? You guys, so here's the situation, a large water heater. Large water heaters are defined not by their volume but by their BTU. When you go over 75,000 BTUs, it becomes large. And watch right here where I'm highlighting, or my cursor's going back and forth over the standby loss. When I go and I drop down my BTU rating, it's going to, and then hit enter, I should have hit tab instead of enter. It now comes up and it shows an energy factor and a recovery efficiency. So at under 75,000 BTUs, the number we use is energy factor. When we go over that 75,000, and I keep hitting tab and I keep hitting enter instead of tab, it goes to recovery efficiency and standby loss. If we go to our import and pull up any of these new water heaters, any of these new large water heaters, they will all have a standby loss there. How you define or how you determine the standby loss of an existing large gas water heater is beyond my comprehension. I can tell you how to do it in the software, but I don't know how to figure it out. There is no way to figure it out. I don't know how you get it. Unless somebody has a good answer for that, and you know, so Steve or Bruce or someone.
I think we should probably wrap things up though, right now.
Okay. All right. You guys. So that's the problem with so many of these things for existing is that we don't. Those values don't exist. There isn't any way to get them. Okay.
So I just want to thank you, Doug, for presenting. I found it very enlightening. Thank you so much for doing that.
You're quite welcome.
So I just want to have a few closing remarks. Thank you for everyone who attended. We hope you found it an enriching experience, and feel free to contact us at info@builditgreenutility.org if you have further questions. I'll just repeat the upcoming webinars that we have. There are some online participation workshops occurring on September 20th, and there's also one on October 18th, both from 2 to 5 p.m. There will be a special webinar for energy upgrade contractors in joint PG&E SMUD territory next Thursday, September 20th, from 8:30 in the morning to 10 in the morning. So that's for all you SMUD contractors out there. And then next month on October 19th from 3 to 4:30 p.m. there will be a combustion appliance safety webinar. So hopefully you can attend one of those. All those webinars can be found, and all our events can be found at www.builditgreenutility.org in the events section. All the recorded webinars can be found in the resources section. So go to that domain and click on one of those sections for the events or to see the past webinars. The slides and the recording of this webinar, provided all technical issues went smoothly, will be emailed to you, and also a link will be, the content will be on the website under the resources section. And it sounds like Doug might even send some bonus material like the start file, so to be determined. Thank you, everybody. That's a wrap unless anyone else wants to add something here. Thank you, everybody. Have a good evening.